In this video, we learn how to write a Python function to solve any given quadratic equation. The general formula for finding the roots of a quadratic equation is given as minus b plus or minus the square root of b squared minus 4ac all divided by 2a. The nature of the roots depends on the discriminant, that's b squared minus 4ac. Depending on the discriminant, the roots of a quadratic equation can be classified as rare and distinct roots, that's if the discriminant is greater than 0, rare but repeated roots, that's if the discriminant is equal to 0, and complex conjugate roots, that's if the discriminant is less than 0. And so to write a Python function to solve any given quadratic equation, we have to include all these cases in our function. Let's implement this in Python. So we first have to import numpy as np. Then we're going to define a quadratic solver function whose inputs are a, b, and c, right? So we're going to define quad solver, and its inputs are going to be a, b, and c. In our next step, we are going to define the discriminant, right? So we are going to say d is equal to b squared minus 4 times a times c, right? So case 1, that's if d is equal to 0. So we are going to define an if statement. That's if d is equal to 0, then let's print that the roots are rare, right? So we're going to print the roots are rare but repeated. And the roots are going to be r1, which is equal to minus b divided by 2 times a, right? And r1 is going to be equal to r2. So you're going to set r2 to be equal to r1, right? So that's the first case. Now let's move on to the second case. Case 2, that's if d is greater than 0. So the statement is going to be else if d greater than 0. So if d is greater than 0, then we are going to print the roots are rare but distinct, right? Then we're going to have r1 to be equal to, so that's minus b plus, then the square root, so that will be npsqrt, then the square root of the discriminant, right? Then all divided by 2a. So we put 2a in brackets. Then R2 is going to be the same, but here this is going to be minus, right? So you're going to copy this guy. Then we change the plus to minus, right? So let's change this plus here to minus. For case 3, we have if d is less than 0, right? That's when we have the complex root. So we are going to use an else statement here. So if d is negative, then you're going to print complex root. So you copy this guy, then you just have to paste it. So since the discriminant is negative, you have to tell Python that the number under the square root sign is going to be negative. So we are going to define the variable called complex d, right? Then we set this guy to be equal to the square roots of complex d. So what this code does is that it's going to tell Python that it should print the square roots within the complex number system. Then R1 is going to be minus b, right? Then plus the variable complex d all divided by 2a. And then R2 is going to be this same guy, but we change plus to minus, so we copy this guy, then you paste it here, then you change this guy to minus. We are going to retain R1 and R2. Retain the root, that's R1, then R2. So this function here is going to retain the roots of any given quadratic equation. Now let's test our quadratic solver function. So we have root 1 and root 2 is equal to So quad solver, right? That's the name of the function. Now let's impute a, b, and c, right? So now let's assume that a is 1, b is -5, and c is 6, right? Now here we have root 1 and root 2 because the function returns two numbers, right? That's r1 and r2. So root 1 is for r1 and root 2 is for r2, right? Let's print the output. Now let's run the code and see what we're going to have. So here we have the roots are rare and distinct. The first root is 3 and the second root is 2, right? Let's use 1 minus 4 and 4. So A is 1 and B is -4 and C is 4, right? So let's run the code and see what we're going to have. So here we have the roots are rare but repeated. The first root is 2 and the second root is also 2. Now let's try that of a complex root. So here A is 1, B is -2, and C is 5. The roots are complex. The first root is 1 plus 2j, and the second root is 1 minus 2j. So that's how you can write a function in Python to solve any given quadratic equation. Thank you for watching. See you guys in the next video.